Time travel, it's like one of those things, right? It just grabs you.
Yeah.
It really does. You think about H.G. Wells and that time machine, or
Absolutely.
like that DeLorean and Back to the Future. It sparks something. And we've been looking at some really interesting material about whether there's any real science behind this idea of time travel. So that's what we're going to dig into today.
Yeah, a deep dive.
A deep dive. We'll look at what the science says, what philosophy has to say about it, and try to, get a better grasp on this wild concept.
Absolutely. We'll start by defining time travel. I mean, what does it actually mean? And then we'll look at the physics behind it. What makes it seem possible, even if just a little, and what seems to shut the door completely. And of course, we have to talk about those mind-bending paradoxes, the ones that make your head spin. And finally, we'll touch on the ethical and philosophical questions that come up if we ever figure out how to, bend time to our will.
So let's start with the basics. Our sources lay it out pretty clearly. What is time travel?
Well, it's the idea of moving through time, but not just the normal way we all experience it. It's about going to a point in time that's not just the next moment, The sources do a good job of breaking it down into two main types. There's future travel, which means going forward in time faster than usual. And then there's past travel, which is going back in time to events that, have already happened.
And from what we've been reading, one of these seems a lot less likely to cause, a cosmic meltdown than the other, right?
Exactly. The physics we understand now, especially Einstein's theories of relativity, they suggest that going to the future might be possible, even though it would be a huge challenge. But going back in time, that throws up some serious roadblocks, mostly because of those paradoxes we mentioned.
Okay, so let's talk physics. Einstein's name comes up a lot in all of this. We're talking relativity, both special and general. How do these theories change how we understand time in the first place?
All right, so special relativity. Einstein came up with it in 1905, and it was a big deal. It said that time isn't this fixed thing, the same for everyone everywhere. It's relative. Basically, the faster you move compared to something else, the slower time passes for you.
Compared to that thing that's not moving?
Right. Compared to that stationary observer. And that's what we call time dilation.
Time dilation. It sounds so sci-fi.
Yeah.
But the sources show that it's not just a theory, right? There's evidence.
Oh, yeah, definitely. Scientists have done experiments with these super accurate clocks, atomic clocks. They put some on airplanes, which obviously move way faster than clocks on the ground. And guess what? The clocks on the planes showed a tiny bit less time had passed than the ones on the ground. It's a small difference, but it's measurable. Of course, to see a big difference, you need to be moving incredibly fast, like a significant fraction of the speed of light.
So if you had a spaceship going almost as fast as light, the astronauts inside might only age a few years, but when they get back to Earth, decades, maybe centuries could have passed. It's like a one-way trip to the future.
That's it. Special relativity gives us a way to travel to the future that makes sense scientifically. The catch is, it's incredibly hard to do with our technology, but the closer you get to the speed of light, the further into the future you could go. It all comes down to how your motion affects the passage of time.
It's really mind-blowing, but going back in time, that's where general relativity comes in, right? With the warping of space-time.
You got it. General relativity came out in 1915, and it changed how we think about gravity. Einstein said that gravity isn't really a force like we used to think. It's more like a bend in space-time caused by massive objects. And this bending, this warping, it opens up some really crazy possibilities, like wormholes, for instance.
Wormholes, those shortcuts through space and time we always see in sci-fi. Is there any real physics behind them?
So wormholes are a solution that comes out of Einstein's equations in general relativity. In theory, a wormhole is like a tunnel connecting two very distant points in space-time. This connection could let you travel huge distances in an instant, or even more interesting for us, it could let you travel between different points in time.
Okay, it's doing a lot of work there. What are the problems with wormholes? Because this sounds like the easy way to travel through time.
Well, there are a few big problems. The biggest one is that we've never actually seen a wormhole. They're still just a theory. And even if they do exist, the theory says that keeping a wormhole open and stable enough for something, even a tiny particle, to travel through would take a massive amount of energy.
Like, how much energy are we talking?
We're talking more energy than we can even imagine creating right now. And some theories say you'd need something called exotic matter to keep the wormhole from collapsing. Exotic matter is weird stuff. It's supposed to have negative energy density, which is a really strange concept. And we've never found any evidence that exotic matter actually exists in the amounts we'd need.
Negative energy. That just sounds like something made up for a movie.
I know, right?
Yeah.
It really messes with our understanding of how energy works. And even if we could somehow find this exotic matter and use it, a lot of the models say that wormholes would be unstable. If you tried to send something through, it might just collapse instantly. And that wouldn't be good for whatever was trying to travel through it.
So while wormholes are an interesting idea, they seem really unlikely to be a practical way to travel through time, especially going back in time. And that brings us to the big issue with time travel, paradoxes. The sources we've been looking at all talk about the grandfather paradox. Can you explain what that is?
Sure. The grandfather paradox is a classic example of the logical problems that come up if you could travel to the past. Imagine someone goes back in time, and for some reason they stop their grandfather from meeting their grandmother. If the grandfather dies before having kids, then the time traveler's parent wouldn't be born. And if their parent wasn't born, the time traveler wouldn't exist either. So the paradox is, if the time traveler wasn't born, how could they go back in time and cause the event that led to them not existing? It just doesn't make sense logically.
Yeah, that makes my head hurt just thinking about it. It seems like reality itself would break down if something like that could happen. Are there any theories that try to explain how to get around this paradox? The sources mentioned a couple of ideas.
Right, physicists have come up with some interesting ideas. One big one is the many-world hypothesis. It's a way of thinking about quantum mechanics. And it says that when the time traveler changes the past, they're not changing their own timeline. Instead, the universe splits into two. A new timeline branches off where the change happened, and in that timeline, their grandfather might not exist. But their original timeline stays the same. So they did travel to the past, but a different version of it.
So you're not erasing yourself, you're just creating a new reality where you might not exist. That's still pretty wild, but it's less of a paradox. What was the other idea the sources talked about? Something about the universe keeping itself consistent?
That's the Novikov self-consistency principle. It basically says that the timeline is fixed. You can't change it. Anything a time traveler tries to do in the past would have to be something that already led to them being able to time travel in the first place. It's like the universe has a way of making sure paradoxes don't happen. So if you tried to stop your grandfather from meeting your grandmother, something would have to stop you. Maybe your time machine would break, or you'd get the date wrong, or something else would happen to keep the timeline the same. It's almost like predestination in a way.
Like the universe has a safety net to protect itself.
Exactly. Fascinating, isn't it?
Definitely. The sources also mentioned something called closed time-like curves. What are those, and how do they relate to time travel?
Oh, those are interesting. Closed time-like curves, or CTCs, are paths through space-time that loop back on themselves. It's a really weird concept. Imagine a path that you could travel along and eventually end up back at the exact same point in space-time where you started, including the same moment in time. Some solutions in general relativity suggest these paths might exist. And if they do, an object could, in theory, travel along this loop and end up back in its own past. But CTCs are very paradoxical, and they raise all sorts of questions about cause and effect. Most physicists think they're very unlikely to exist in reality.
So even if the math allows for these crazy things, the universe itself seems to have safeguards in place. And speaking of safeguards, the sources also point out that building a time machine with the technology we have now is basically impossible, right?
Yeah, that's a big one. Even if we could figure out how to make a wormhole, the energy needed would be astronomical. We're talking way more energy than anything we can produce right now, or even dream of producing in the near future. Warping space-time like that takes an insane amount of energy density. And then, like we talked about, there's the problem of keeping the wormhole stable. We'd probably need exotic matter, which we haven't even proven exists yet.
And then there's a question that the sources bring up, and it seems kind of obvious. If time travel to the past was possible, wouldn't we have seen evidence of it? Where are all the tourists from the future messing around in history?
This is a good point. It's kind of like the Fermi paradox, but for time travel. The fact that we haven't seen any time travelers could mean a few things. Maybe it's just impossible. Or maybe there are rules about time travel that we don't know about. Rules that prevent time travelers from being obvious. It's a real head-scratcher.
It makes you think about the nature of time itself, you know? So moving beyond the strict science and paradoxes, the sources also talk about some ethical and philosophical questions that come up if time travel was real. That seems like a whole other can of worms.
It is a big one. Imagine the ethical problems we'd have. Would it ever be okay to change the past, even if you thought you were doing good? What kind of unexpected, maybe even disastrous consequences could come from small changes? The sources even talk about whether we need rules or laws about time travel. It really does open up a Pandora's box of ethical and societal issues.
And then there's the big question of free will. If the past is already set and the future's already planned and we could just move around in this timeline, does it mean our choices don't matter? Does it mess up the whole idea of free will?
It really challenges how we think about cause and effect and whether our choices really make a difference. If what we do in the past is already part of history, or if changing the past just makes a new timeline, it makes you wonder how important our decisions really are. These are huge philosophical questions that people have been debating for centuries, even before we started talking about time travel scientifically.
It's amazing how this concept, time travel, something that seems like it belongs in science fiction, makes us think about such big questions about the universe and our place in it.
It really is. Even if we never actually build a time machine, just thinking about the possibility makes us think harder about time, cause and effect, ethics, and even the nature of reality itself.
Okay, so let's try to sum up what we've learned from this deep dive into these fascinating sources about time travel. What are the key scientific takeaways?
Well, scientifically speaking, special relativity has shown us that time dilation is real. It's something we can measure. And it might give us a way to travel to the future. The problem is, it would probably be a one-way trip, and it would require us to travel at unbelievable speeds. Then we have general relativity, which gives us the idea of wormholes, those shortcuts through space-time that could connect different points in time. But wormholes are still theoretical, and they would require exotic matter, which is something we've never seen. Plus, they'd be very unstable and take a huge amount of energy to create. The main thing is that, right now, science suggests that traveling to the future is more likely than traveling to the past, which is full of paradoxes.
And those paradoxes, especially the grandfather paradox, they seem to be the biggest problem with past time travel. Do any of the sources offer any solutions to these paradoxes?
They do. The sources talked about a couple of really interesting theories. The many-worlds hypothesis says that when you change the past, you're actually creating a new timeline, a new universe, where that change happened, but your original timeline stays the same. Then there's the Novikov self-consistency principle, which says that the universe is built in a way that prevents paradoxes from happening.
Right.
It's like the universe has a built-in protection against breaking its own rules. But remember, these are just theories. We don't have any proof for either of them yet. The debate is still going on.
And we can't forget those big what-if questions, the ethical and philosophical questions that would come with the ability to actually change time. That's a whole other level of complexity.
You're right. If we could change the past, it would bring up some incredibly complicated questions about cause and effect, free will, and whether it's morally right to mess with the timeline. These philosophical questions are just as important and maybe even harder to answer than the scientific problems we've talked about.
This has been a really deep dive into something that just fascinates people. So after looking at all of this, the scientific possibilities, the paradoxes, how unlikely it is with our current technology, it really leaves you with a big question. If time travel to the future is possible, at least in theory, through those relativistic effects we discussed, what would it mean for us as a society or even for individuals if we could take a one-way trip to the future? Imagine going to a future that's totally different from what you know, with no way to come back to the life and people you left behind. What would that do to humanity? What would it do to the person who makes that leap? It's something to think about, even after this deep dive is over.
Absolutely, something to ponder.
Yeah, it really makes you think.
It does.
Thanks for joining me on this one. It's been a mind-bending journey.
It has. Thanks for having me.
And for everyone listening, keep those questions in mind. Until next time, keep exploring the universe and all its mysteries.
And its paradoxes.
And its paradoxes, absolutely.
Keep wondering.
Keep wondering. See you later.
Yeah, see ya.